Hi all, hope you can hear me. Can we start? Felix. Hello, can we start? We had already talked about control structures, but because of some issues that were in this country, we are supposed to start from control structure. And I think you have received some notes. Have you received some notes?
No.
There are some notes that are on your portal, and I think you can maybe look at them. Can you see them?
Not.
Okay, please, can you make sure that you look at them, because now we will be using those notes, and there are some things that you still be able to learn from there. And if we can start, hope Madut can hear. Call and Felix. Hope you can hear me. Am I clear? So if you look at control structures, we are supposed to understand about how the statements are supposed to be executed. And when you're executing them, you have to look at various statements that you are supposed to use in order to execute them. And most of these statements, we have one of the statements which is called sequence control structure. And then we have another one which is called selection or decision control structure. Then we have another one that we call looping, or what you call iteration control structure. And if you look at those control structures that you always have, we always start with the first one, which is sequence control structure, which we always say that it is the flow of execution. Like now, there are those processes that you always take when you are doing your core jobs, where we are supposed to start from a given point up to the end. Like now, if you can say, for you to do an exam in school, you first of all attend classes. But before you attend classes, you have to register with the school. So the first process is to register the school with the school. The second one is now to attend classes. Then after that is to do cuts and assignments. Then after doing assignment and cuts, the last point is now to execute by doing the end term exams. Then the farthest most is now where we have the result slips. So you can, before you do an exam, that is something that is shareable on that. And that's why we say those are processes that you take from one day up to the end. But if you look at now, other control structures that you always have, which we call decision or selection control structure, in most cases, we always look at a various aspects where we can be able to say we are having different statements that we have. One of them is what you call if control structure. Then the next one is what you call if else statement. And the next one is if else if statement. So for those statements that you have, there is one of them that is repeated. And that one that is repeated is what you call the switch statement. And if you look at most of those statements, I will be using paint to demonstrate on that. And if you cannot see this demonstration, please, you can tell me so that I can share on that. Can you see that paint that I have added on that? Can you see it?
And they used to shut some.
Can you see the paint?
To come into Nairobi, they shut down.
Okay. Can you hear?
Rather than that water coming down into Nairobi.
So if you look at paint, we are saying one of them, we have what you call the if control structure. And the first thing that we need to understand is the syntax, where the syntax of this is where we start with if, you open with curly brace, then After that, we have statement. Then we can close. So what we are saying is that we have if condition, if, and when you're talking about condition, we are saying the condition can be true or false. But because now we are using the if statement, the condition is always true for you to execute. But if it is false, it is supposed to end at that point when you're executing that statement. And that's why we always say that in most cases, if you can look at the presentation of a loop, because we can use what you call decision, we can use loops within that, but there is one flowchart that we can use, and I think you can see this flowchart that I have here, where we say we have the condition, then after the condition, if the condition is true, now you execute the statement. But if the condition is false, you end the statement. Meaning, we are only executing one statement, but we cannot execute two statements at the same time. And that is why we need to understand that we can now come up with a various presentation of various programs that we can use the if statement, where we say, if we can use our interpretation of our code that we have here, we are saying we have a variable that we have declared, a variable A, and this variable has been initialized a value of 10. Then we need to test whether this value is within the confine of a statement that is being introduced here, which is now 20. And that's why we are saying, if A is less than 20, where we know 10 is less than 20, is this statement correct? So if this statement is correct, we are supposed to get an answer. And that's why we are saying, if A is less than 20, that means we are moving from 10 or from 0 to 19. And then we say A is less than 20, which is true. But if it is false, the statement is supposed to end. That's why we are saying, if we can introduce a condition, always a condition is supposed to be true. But if it is false, it ends. Like now, if you can use maybe voting, a person is supposed to vote when he or she is above 18 years old. But what if you are below 18 years? So in this, we are using some conditional statements where we are using an operator, and this operator is relational operator. We are saying if age is less than or equal to 20, which is true, we are not supposed to vote. But if it is greater than that, we are supposed to vote. So for this case, we have already executed one, but what about the else statement? That's why we have some bottleneck within these statements, because we have not catered for else statement. So can we now use else statement? And when you're using the else statement, we only add else statement after we execute if. And that's why we are saying the if else statement lets the programmer choose between two statements. But previously, we were only choosing from one statement, as opposed to the simple if statement, which we have already discussed here. And if you look at the syntax that has already been provided here, because the syntax is how the statement is supposed to be presented, we are looking at now if Boolean expression. Is this Boolean expression true or false? If it is true, what are we supposed to do? But if it is false, now we can cater for that. So what we can now say is that if we are having a statement and we use a decision, and this decision that we are having, we try to say is, if it is true, which statement are we supposed to have? So we can now introduce a statement. But if it is false, we can still introduce another statement. So for this case, we have catered for two statements, true and false. But if you look at the first one, we were only catering for only true statement, which is a mess within the interpretation. And that is why now we have a program here. We can say, if this person has a variable I, and this variable I, we want to test whether this variable is an even variable. So we now first of all enter this, the way we have entered. So we have declared a variable I, then we enter this variable. And for now, we know how you enter variables. And if there is a question on that, you can ask. Then if I is I modulus 2. So if you can remember what we said about modulus, we said we are testing the codation, but we now get the remainder of our division. And when you get the remainder of our division, let's assume the value that you have entered is variable 5. If you try to divide this variable 5 by 2, we get 2 remainder 1. So if now the remainder is 1, this means it is an odd variable. But now, if you can tell here, we are saying, if I modulus 2 is equals to 0, then it is an even number. So can you execute that even number? So we will say is even. Is even what? If it was 4, is even 4. Else is odd. Because now we have already catered for the else statement. And that's why if you look at the flowchart that we are having here, we are having a codation. Then this codation is tested. And if this codation is tested, if it is true, you give the first chord. If it is false, you give the second chord. And then they end at the same point. So for this case, we have already catered for true and false statement in this. But now, this one has already catered for two statements. What if we have multiple statements? And the multiple statement is when you are talking about grading. Let's say maybe we are talking about grading. And when you're talking about grading, we can say from 0 maybe to 40, this person gets an E. And this is now this is the grade. But these are the marks. We can represent that with M. Then from 40 up to 50, maybe we have a D. Maybe from 50 to 60, we can have a C. Then from 60 to 70, we can have a B. Then from 70 to 100, maybe we can have an A. So if this is a grading system, and we are using this grading system, we can look at this statement that we have. These are 4 statements. These are 5 statements. 1, 2, 3, 4, 5 statements. So you must cater for these 5 statements that we are having. And for you to cater for these statements that you are having, you cannot cater with if-else statement. So in this case, we have to introduce what you call if-else-if statement. And that's why if you look at my notes that I have here, I will send these notes the way they are. You are saying this is a control structure that is used when more than 2 choices have to be made. So here we are making 5 choices to be true or some to be false. And for this case, that's why we have a syntax, if expression 1. And when you're talking about expression 1, we are saying if, in bracket, the first condition. If it is true, you get the first statement. If it is false, can you test this? Now, if I can ask a question, given the statement that we are having here, is 40 included in grade E? So somebody can answer that. Is 40 included in grade E?
No.
It is not included in grade E, because now you can look at this point. 40 is starting in the second line, which is at point 2. That means from 40 to 49, that is where we have a D. From 50 to 59, that is where we have a C. So if you understand this, you can now come up with a different presentation for this. Let us first of all understand the syntax, because when you are doing your program or when you're doing your programming, first of all come up with your syntax. Then after that, you come up with your flowchart. So if you understand the syntax, it's very easy for you to come with a flowchart. So for this, you can look at this point where we are having else at the end of else if. And remember, else if is 2 ones. We are not connecting else if. We are having else if as 2 ones. But after introducing it from the first statement that we have, if expression 1 is true. If it is not true, can you go to the second one? So can you test that? Let us try to explain this, maybe using a flowchart. And I want to maybe come up with a flowchart here. So the first thing, we introduce a decision. If these decisions are not clear, at least maybe we can maybe use this. So we are using this decision. And this decision, maybe we try to say whether it is true. So if it is true, what are we supposed to have? So if it is true, let us have the first statement. So if it is false, so we can now introduce the next one. So if it is false, what are we supposed to have? Now, if you look at the previous one, we were introducing a statement here. We were introducing a statement here. But for this, we are not supposed
that you think for something. Actually, when you come back,
you are now for that states that we have. For this hand,
You are currently the only person in this conference.
are using a varying value, can you hear me now? So if you can use a switch statement, we are using a constant values. And when you're using an if-else statement, we are using a varying values, which we call the variables values. And in this case, we need to understand about this syntax of switch statement. And what we have said about the switch statement, we need to first of all understand that we have a case keyword. And the case keyword that we have, we are saying case constant 1. Then we have case constant 2. And when we are using a case constant 1, we are saying, suppose we have a constant A, which is capital A and a small a. We are saying switch variable. So we can say variable that we have already declared so that we can enter A or A small or A capital. So if it is capital A, what are we supposed to get? We are supposed to get letter A. Then, if it is not true, let us go to the second one. So that's why I have said we are using case A capital, case A small, then we break. And I have tried to explain break. I have said when you're using break, when we reach at a certain point, we end the execution. But when you're using continue, we now jump those statements. That's why we have said if you're executing 1 to 10, if you're using break, if A is equal to 3, break. So we are saying 1 to 3, can you end the execution? But the moment you're using continue, it is supposed to jump 3. So we are executing 1, 2, 4, up to 10. Because now we have already jumped 3. So meaning that now it is very clear in this presentation that a break is the one that we are supposed to use in our control structure the moment we are using a switch statement. And that's why I have said we are using case constant 1. And we can try to understand this program. And that's why I have said when you're using the else statement in if-else statement, we don't use else, we use default keyword. And if you look at this flowchart that we are having, we are using expression, case 1, case 2, case 3. If case 1 is correct, let us have the statement. If case 2 is correct, let us have the second statement. If case 3 is correct, then after that you can break. But if all these conditions are not satisfied, we can now jump to default. So in this case, let us understand this program that we are having here. And I think you can you see this program that I'm trying to explain here? Can you see the program? Is it clear now? Can you get the program that we are explaining here? Please, can you say yes or no? Members, can we hear? Okay, so I have heard from Peter Otieno, it is clear, so I can continue. So what we have said is that we are trying to test a certain condition here. So it's going to create a simple calculator for addition, subtract, multiplication, and division. But we need to use a switch because now we have a constant variables here. And a constant operator is plus, minus, multiplication, division, etc. When we are saying, let us try to declare a variable, and this variable is the one that is supposed to cater for these operators. But now the question is, how will you know that you are supposed to use a character when you are defining a plus or a minus? Remember, a plus is not a variable. It is not a value. It is a character. That's why we have defined it as a character. Or. It is not a must to use or. We can use K, we can use L, we can use letter, etc. Then we declare two variables that we are adding, and we are adding after we enter the operator through our console. Enter the operator, either plus or minus or multiplication or divide. So if you look at this statement, it is supposed to execute the way it is, because this is a string. Then scan F. we now introduce a character specification, because we said when you're using a character specification, we are now defining a memory that is supposed to present a character. Then after that, we have defined two integer values. And then we say case plus. When you say case plus, we are saying printf percentage long float. Remember here we are using long float because we have used float num1, num2. When you use double, we say to use f without l. Long float plus another long float. We are adding num1 plus num2 is equals to the result. So it is the same as saying a plus b is equals to maybe what? If a is equals to 5, b is equals to 5, we are saying it is now 10 because we are adding that. So what we can say is that we can look at this point and say a is 5. Maybe if you are using num1 is 5 and the other one is 5, 5 plus 5 is equals to 10. So that's why we are adding that, num1, num2. Then if this one is not correct, if you have not pressed plus, you have pressed minus, that is when it tests the second condition. Remember we have used break, and the way I have explained break, I have said in break statement, we are supposed to understand that a break is supposed to terminate the condition if it has been certified. So terminate this statement if you have already certified what we are supposed to execute here. Then if you try to execute all the statements that we are having, if these operators are not satisfied, suppose I use a modulus, maybe I use percentage. When I use percentage here as an example, maybe I use percentage here, which means it's a modulus. So it means modulus is not catered within our presentation. That's when we need now to execute default. And when you execute default, it means error operator is not correct because it is not within the storage of our inputs that we have. So for this case, we have already tried to understand that most of the conditions that we are supposed to have here, we can either test using if, we can either test using if else, we can either test using if else if statement, or we can use switch. And that's why I have already said in your program, you'll not be told whether we are using switch statement or if else statement. What we need to know is that the program is asking you to create some programs, but you need to ask yourself whether you are using switch or if else or if statement. And that marks the end of what we are supposed to understand about the decision control structure. Remember, in decision control structure, we have if else, if statement, if else, and switch statement. Note that. And as the name suggests, we are looking at decision. There are many alternatives, but you only have to select one alternative at a time. You cannot select two alternatives at the same time. Please, members, I want to get some feedback from you, whether you have understood what I have explained or whether you have seen the notes, of which I will be able to send those notes to you again. Remember, now you can raise up some issues on that. And remember, when you are talking, you can switch your mic on, please. I'm waiting for answers, for questions, sorry. Members, waiting for questions. Are we okay? Are we understanding? So can we answer the questions? Rachel, can you answer the questions? Can you ask the questions? I'm waiting. You can switch on the mic and we communicate. Peter, are you understanding? So can you ask any question, Peter, please? Ask question. Rachel, I can see you are typing. Peter, I can see you are typing, so you can talk. There's an open forum. You can talk. Is there any question? Rachel, Peter? Okay, I will share the notes as Peter has said. I will share the notes. Still, I have sent some notes there, but I will still send others so that you can understand more on that. And I want us, first of all, to introduce the next grouping so that after the end of those grouping, we can now go to chat room and be able to chat. There will be some questions that I will be asking so that you can answer the questions. Remember, we still have 2 hours that you are supposed to go through this course or this unit for today. So please, I will be using wikis. I will be using chat room so that we can share some other things that we have not understood, please. Because there are some questions that I will still ask. And I want us to introduce the next part, which is called looping. And when you're talking about looping, this is where we need to understand about program executing many times or multiple times. And when the program is executing multiple times, and I think you can see those notes. So if you can't see those notes and you can't hear, please, before we continue, maybe you can raise those issues so we maybe correct that. Can anybody hear and see? So if you can see the screen that I'm scrolling, the notes, maybe you can say yes or no. Just type or communicate. Can you? Okay, you can see. I can see. Grace can see and can hear. Peter, can you see? Grace? Grace is okay. Felix or what? Okay, so we can maybe continue. If you look at looping, another name for looping is repetition. Or another name is what you call iteration. It is also called iteration control structure. And if you look at the explanation, we are saying these are the statements that are supposed to be executed multiple times. So we are trying to solve a problem that was encountered in the previous loops, that in the previous control structure that we have already discussed. Because if you cannot repeat some statement or you cannot repeat statement several times, it becomes an issue. So that's why we are saying in a finite loop, the number of iterations is determined and set by the programmer. So being a programmer, as a programmer, you need to set the number of times that you are supposed to execute those statements. And if you look at most of these control structures that we have, or the statement that we have in this control structure, one of them is what you call the while loop. While loop. The next one is do while loop. Remember, we have do, then there must be a statement here, while loop. I will discuss do while loop the moment we start discussing do while loop. Then we have a for loop. If we start with a while loop, in a our explanation, we can say this is when the condition is supposed to be true. But if the condition is false, we are supposed to end. Despite the number of times that you are supposed to execute the statement, the condition must be true. And if the condition is false, it is supposed to end. But how will you make this condition to be true? So what we are saying is that we can look at this point where we are saying, while the condition, then this condition, if the condition is true, execute the statements. If it is false, end. Let us try to understand this syntax that we have. We are saying, while condition statements, if the condition is true, execute the statement. But how will you make this condition to be true? That's why when you're using the while loop, we first of all initialize. Well, we can say, we can initialize this value and say, while maybe we have int num1. Then we say num1 is equals to 0. Then we end. Then we say while num1 is less than or equal to 10. So we are saying if num1 is less than or equal to 10, meaning we are now counting numbers 0 to 10. Then after that, we can say if num1 is less than or equal to 10, what are we supposed to do? We execute the statement. So we can say printf then we have an execution of this statement. We say %d. Then we say num1. Then after that, we can end. Then after that, we end this. We can now look at this presentation and say, while num is less than or equal to 10, printf num1. But what about now the next num? That's why we say num plus plus. So in this case, we are saying while num is less than or equal to 10, printf num1 num plus plus. So I test the first one. Is 0 less than or equal to 10? It is. So we execute 0. So the first thing that we write 0. Then after that, we go to the second num. So it is adding num plus plus. So 0 plus 1, because it is num plus 1. 0 plus 1. Is 1 less or equal to 10? Yes. So we execute 1. Until now, a point where we cannot execute the number which is greater than 10. So in this case, what we are saying is that the statement we are having here, we are now saying the first condition is true. And if this first condition is true, we execute the condition. So it repeats until the condition is false. So if the condition is false, that is the time that the statements are supposed to end. The same case we are looking at this explanation here. Because we are saying, if this num is 11 now, because we have tested up to 10, if it is 11, now can we end that condition? So for this case, we can now say that we have executed the statement from 1 to 10. But if it is now 11, this program is supposed to end completely. And if you look at the explanation here, it has already ended with those statements. So let us try to understand this program that we are having here. So we have a program to add numbers and compute the average. So add numbers, then compute the average of those numbers. So the first thing is to declare the variables. And when we are declaring the variables, we are declaring n. Then we have to declare x, which is the variable, which is now the value that we are supposed to add. Then the average, remember we are calculating the average. Remember still we need to get the sum. How many numbers? So this statement means how many numbers do you want to work with? How many numbers do you want to work with? So when I say n is 5, so I'm supposed to work with 5 numbers. When I say n is 20, I'm supposed to work with 20 numbers. When I say n is 1, I'm supposed to only work with 1 number. While count is less than or equal to n, remember we have already conditionalized here, and we have said the condition is supposed to be true. So when you say while count is less than or equal to n, where n, we have said we want to work with 5 numbers, then print x. Then we are saying x, this is the output statement. So scan fx. So this is the number or numbers that we are supposed. If I have said I want to work with 5, I can enter 6, 7, 8, 9, 10. Maybe those are 5 numbers. Then after that, we say sum is equals to x. So we are adding here, and then we count plus. This count plus, we are saying these numbers, because they are 5, we count until we reach at 0.5. Then average is equals to sum you divide by n. So this is the number of numbers that you have already entered. We have said I want to work with 5 numbers. So sum divided by the numbers that you have, then we execute that. So in this case, we have already tested the condition, and the condition that we have already tested, it is true for now. Because now count, we are saying we work with 5 numbers. Is 1 less than or equal to 5? Yes, it is. So let us now see those numbers. Now enter those numbers: 5, 6, 10, 11, 15. Then after that, can you add the sum of those numbers? So if you try to do that, if you have already said we are working with 5 numbers, 5, 6, 7, 8, and 9, so you add this. So when you add these numbers, because now n is represented by 5, where counter is now the initialized value, which is now initialized to 1. So for this case now, we are now able to calculate the sum. Remember that for you to calculate the average, you divide sum divided by the number of numbers that you have, that is n, and you get that. So if you look at these programs, we have already said this loop that we are saying while loop, first of all, it must be true. It must execute until it is false. So when it is false, that is the time that it's supposed to end the execution. But remember, this loop is starting with the condition. We are starting with the condition. Suppose we want to start with a statement. So we use do, then we have statement, then after that, we can have while. Then we have condition. Remember, when you're using this, we must end with a semicolon. So this is now when you are supposed to end. Do, we open, statement, we end, while this. So what we are saying is, if we can look at this presentation that we are having here, maybe we can say, the syntax says do, statement, while condition. Remember, we are ending with a semicolon, meaning now the while condition is not a condition now, it is termed as a statement for now. And if you look at now the flowchart that we are having here, we are starting with the condition. Then if we are starting with the statement. If the statement is correct, we now execute the condition until it is executing until it is false. So when it is false, that is the time it's supposed to end. If the statement that you are supposed to test, it is not given here, we end the condition. What we can say is that, suppose I want to print numbers 1 to 10, maybe 1 to 10. I will say, do, then we open the statement. Then after opening that, I say printf, then we execute percentage D. Then we execute num. Remember, we have declared num here. So we have declared maybe an int num. Then after that, we end with a semicolon. But remember, we must update this statement. And when you're updating this statement, that's when you say num plus plus. Then when you say num plus plus, then we close. Then you say while the num is less than 10. Then we end with a semicolon. So we are saying we execute the statement first. Then after that, we now update those statements if it is true as certified by the condition. Then after that, it ends when the statement is not correct. So if you look at this statement that we had here for a while loop, if you look at a while loop, there is a point where we said, if I have not deleted that. So we are saying we are starting with the condition, then statements, then we add at that point. So if you can look at the difference between a do while and a while loop, is that a do while start with a statement, while a while loop start with a condition. That is a clear differentiation of those two things that we have defined here as a loops. If you look at those two, we are repeating several times, because if you look at now from 1 to 10, we are repeating 10 times. And when you are repeating 10 times, we have to understand that now we have to cater for those repetitions that we have. And that's why we have to understand how we are supposed to use these loops. And that's why I've said you never see any examiner asking you whether we are supposed to use a do while or a while loop. It is up to you to decide which loop you are supposed to use at that point, if it is repeating several times. And the first thing that you need to understand is now we understand the flowchart, because we said, if you look at the steps that we said about program writing, we said we must use some design tools. And one of the design tools that we can use is the flowchart. We can use the pseudocodes. But for now, we are using what we call the flowchart. So for this program, it works together with that. And we can still interpret another program here when you're using a do while. And this program is testing a certain value. And the value that is given is starting with 0. So we are saying int value is equals to 0. So we have already initialized the value. Remember, we have to initialize the value. First of all, to make it true, do if value modulus 2 is not equal to 0. Suppose now the value that you have already entered is 10. And we say if 10 modulus 2 is not equal to 0. Well, we know that 10 modulus 2 is equal to 0, which is true. So if it is not equal to 0, we are supposed to get a value here. But for this condition, we are saying if value modulus 2 is not equal to 0, so we are supposed to do something. The value is value. So suppose you have 9. If you divide 9 by 2 and the remainder is not 0, because if you look at 9 divided by 2, the remainder is 1. So it will say the value 9 is 2. The value 9 is 2. Then we have already introduced a while loop. The value is less than or equal to 30. So the numbers that you are testing here are from 0 to 30. From 0 to 30. So if the number that you test in between 0 and 30, and the number, when you divide it by 2, the result will not be a 0, it should be displayed. So you display that value. So here we are not displaying the values that are not we are not displaying the numbers that are divisible by 2. We are displaying the numbers that are not divisible by 2. That is the case here. And that is why we need to understand that when you are using the if, we are testing the values, but here we have introduced the condition satisfaction, and this condition satisfaction is where we are testing the even numbers. And when you test the even numbers, we are not supposed to display those even numbers. The numbers that we are supposed to display are the odd numbers from 0 to 30. Hope you are understanding that. Is there any question up to that point? Is there any question? As you wait, I send those notes to you. Is there any question? Are we together? Felix, Grace, Peter, Rachel, are we together? Kor Madut? Kor Madut, are we together? So if you are together, we can maybe say yes or no. If you're not together, we can say no. Maybe I repeat that. Okay. So I have seen an answer from Peter. We are together. What about Felix? Okay, yeah, okay. Now, Grace, I'm waiting for you. Madut? Are we together, Madut? Is Madut in? Okay. Okay. We can continue. I'll send notes so that now we can maybe have a chat room so that we can discuss that. And if still there is a question, I can still repeat that. Or you can listen after this. Remember that this clip is recorded. You can still see that after the lesson. So the next one that I want us to start with is the for loop. Remember, there are 3 statements that we are supposed to discuss here. We have while loop, we have do while, and we have for loop. And when we are using these loops, the best one to use and the best one that we'll be using mostly in an array, because that is the next topic that we need to discuss, we'll be using loops, for loops. In a for loop, we can execute statement at once, all the statement at once. Remember, for others, we are executing one statement after the other. And if you look at the first interpretation, because I want to start with the syntax, we are starting with for int. That is the initial. That is the integer value. So first of all, initialize the value. Then we have codation. The moment you're using codation, we are testing the variable that we have here. Then we increment. That's why we say we test the statement at once. So meaning, if I can try to interpret this with writing, I'm saying maybe I declare int num. Just a minute, just a minute. So if I'm using int num, maybe we have int num, and we have a semicolon. So we say for num is equals to 0, semicolon. Remember, in a syntax, we have a semicolon. Num is equals to 0. Num is less than or equal to 10. Num plus plus. Remember, we are saying num plus plus because we are adding one after the other. 0, 1, 2, 3. Suppose I want, maybe I want to say you add by 2. 0 plus 2, 0 plus 3, etc. So I will say num is equals to num plus 2 here, where we have num plus plus. So I replace num is equals to num plus 2, where we have num plus plus. Then I have to open this bracket with a curly brace. Then after that, I have statement. So the statement is print f. So you print f, and we are printing what? Percentage d. Remember, it is an integer, but we print num. Then we end. Then after that, we can end our parentheses. So in this case, we are saying we are executing numbers 1 to 10. And when you're executing numbers 1 to 10, it becomes easier when you're using a for loop. It's not like when you're using what you call a do while. Because when you're using a do while loop, sometimes it becomes hard for you to try to interpret or maybe to position where the statement is supposed to be. But when you're using a for loop, becomes easier. That's why we are saying we'll be using this in an array so that we can be able to understand how the array works. So if you look at now the flowchart, we have already declared a variable. Then this variable, we test that variable. When you test this variable, and this variable is true, if the condition is true, let us have the first conditional statement. Let us have the first conditional statement, then we increment. Remember, we have already incremented. Then after that, we go back, we increment the second value. So in this case, we can now say that now we have executed multiple statements, but this multiple statement, we have executed them once. It's not like when you're executing using the do while or when you're using the while loop. Because in a do while, we are executing one statement after the other. But for this, it allows you to execute statement at once. So one, you trace less memory. Second, there is speeding up of execution, because now when you're using a for loop, you speed up the execution of those statements that you have. Even if you have millions of them, you can execute them. And for this case, it allows us to use patterns. There is an assignment that I will send, and for any question that you can ask from those assignments that I will send, maybe you can raise the question, because I will be expecting you to use a for loop when you're using those patterns. If you look at the question papers that I gave you, there are some patterns, mostly asterisks, we have numbers, we have letters, etc. And those are the ones that we'll be discussing in the chat room, because we need to understand more. I will be asking questions and grading them. That's why we need to be serious in this, so that we can be able to complete the course before the time that we are supposed to sit for an exam. So if you look at the interpretation, I have already interpreted the for loop, how it works. I will not interpret that for now. I will send those notes. But what you need to understand about these loops, we allow the for loop when we are using arrays, and it allows us to use what you call the nested loops. And the moment you are using the nested loop, it allows us to execute more statements at the same time. Remember, we can now interpret this statement and be able to work with this statement with views that now users can be able to get more interpretation for that. So if you look at the explanation for this program that we are having here, mostly we need to understand that we are using a loop inside another loop. And the moment we are using a loop inside another loop, what we need to understand is that this loop is supposed to create an inside and an outer loop. And the moment you're using inside and an outer loop, it means one loop is more superior than the other. And that's why I have said we'll be using these in patterns. So for now, we can first of all understand this program, because there is a pattern that we have interpreted here. We are saying we have two variables, int I, int j. For j is equals to 2, for I is equals to 2, I is less than 100, I plus plus. Then we have j is equals to 2, j is less than or equal to I divided by j. So if I is 2 and j is 2, so we are dividing 2 divided by 2. So when I is 2, j will be 1. That is the interpretation that is here. And for this case, we understand that now we can use a clear presentation for this loop. Let me try to use an Excel, maybe so that we can see the patterns that I'm talking about, which is very clear. The multiplication table, there is a multiplication table in your notes. And that multiplication table, you can use it. Maybe you can have one here. Maybe here we can have one, and here we can have 2. Then we can have 1 here. We can have 2. Here we can have 3. Then we can have 1, maybe 2. Then we can have 3. then here we can have 4, then we can have 1 here, we can have 2, then we can have 3, then we can have 4, then we can have 5. So if you look at this pattern that we are having here, let me use Buddhas or Buddhas. If you try to use this, if you're in the first row, because there is the first row, the second row, the third row, the fourth row, and the fifth row. But for this one, there is the first column, the second column, the third column, the fourth column, and the fifth column. So if you are in the first row, we're in the first column. If you're in the second row, we have 2 columns. If you're in the third row, we have 3 columns. If you're in the fourth row, we have 4 columns. If you're in the fifth row, we have 5 columns. So for this one, neither is controlling the other, but the first one is the outer loop. And this outer loop that we are having is a row loop, because now the row is the one that is determining whether we should have a column. And for this case, now we can introduce a variable. Let me try to use an interpretation for that program here. And we can say, if you are having an int R and a C, row and column, we are saying for row is equals to 1, row is less than or equal to, row is less than or equal to 5. Remember, we have how many columns? We have 5 columns and 5 rows. So what we are saying is that we can now say, if you're in the first row and we are controlling 5 rows, then we have row plus plus. Then we close that. Then we open this, and then we can have now another inner loop. And the inner loop is now for the columns. So here we can introduce columns. Remember, we are saying for R is equals to 1, R is less than or equal to 5, R plus plus. For column is equals to 1, column is less than or equal to 5, column plus plus, then we open that. Why are we saying that? We are saying this because if you're in the first row, we are in the first column. If you're in the second row, we have 2 columns. If you're in the third row, we have 3 columns. So they are working together. Rows and columns are working together. And because they are working together, that's why we have said row is equals to 1 and column is equals to 1, controlled by 5 columns and 5 rows in that. Then after that, we can print, but what are we printing? We print F percentage D. So we can close that, percentage D, but we execute rows. We are executing rows because first of all, we are now executing rows, then we execute columns after rows. Because row is the outer loop, but column is the inner loop. Then after that, you can end. Then you end those loops. So I'm adding the inner loop, then you end the outer loop, and the result will be this when you're using programming language. So I want you to use def++, and I think it is not new to you, or you can use what you call the code block. You can use the code block, or you can use what you call the Visual Studio or Visual Basic 6.0. So those are the programs that you can use so that you can clear that program the way it is, and you'll be able to understand more the moment you'll be writing that program and you execute it. And I think it is not new to you because we had already started executing programs, simple programs, where in this program, you must save as .c, e.g., we can say maybe we have first program, first program, you save it as that first program.c. So that's now it can allow you to execute that program. So next time I'll interpret that using a program. I will be coding as you maybe continue with this discussion so that we can be able to understand more in this programming language that we are discussing. So in this case, we have already talked about for loop, and we have said we can use for loop to execute patterns, So I want you to try this. Maybe you can have a program that have one. Maybe you have one, we have one, we have one, we have another one. Maybe we have two, we have two, we have two, we have another two, we have another two, we have three, 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 three. Then we have four, 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 four. Those are programs, but now you need to ask yourself, is the row controlling columns, or is it the column controlling rows, or who is controlling the other? So first of all, come up with that interpretation. So I want you to try that. Maybe you can still try this. Maybe you have 1, 2, 3, 4, maybe 5. We have 1, 2, 3. We have 4. We have 1, 2, 3. You have 1, 2. Then you can have 1. Remember now, we are starting with the 5 columns first. Then we end with 1 column. We are starting with 5 columns. We end with 1 column, and many others that we have. If you look at the question paper that I gave you, still it has those questions, so you can try to come up with that. You can still use a multiplication table, where maybe I can use a very simple multiplication table of maybe 4 values. And this is the first one. Maybe we can have another 1, 2, 3, 4. So if you multiply 1 by 1, this becomes 1. 1 by 2, 2. This becomes 3. This becomes 4. You multiply this becomes 2. 2 multiplied by 1. Then 2 multiplied by that becomes 4. 2 multiplied by this becomes 6. And this becomes 8. This becomes 3 because you are multiplying 3 multiplied by 1. This becomes 6. This becomes 9. This becomes 12. This becomes 4. This becomes 8. This becomes 12. And this becomes 16. This becomes 16. So this is a multiplication table. If you look at these are the ones that we require to understand. So we are multiplying rows and columns. So the moment we are introducing, we will be able to introduce rows and columns. But here we say we have how many rows? 4. Here we have how many columns? We have 4. But here we can say we are multiplying rows multiplied by columns, so that we can execute that. But remember, now this is now the interpretation when you're using the multiplication table in that. So for this case, we have already done few patterns. And there are other patterns because if you look at now online, they are online. You can still see them online and be able to understand them in online platform. So I want to reach at that point. And if there is a question, because maybe we can have questions. I know there are many questions that we can ask so that we'll be able to understand. Remember, I will send those notes. I will still send some questions. Remember, we are moving from here up to chat room because our lesson ends at 2. And we'll be able to share more in wiki. And still, we'll be able to share more in chat rooms. So is there any question up to that point? Because I want to end at that point. Any question? Any question? And I wonder whether you can maybe talk, because now you are typing. Mine agrees. Is it possible for you to talk? What's the issue? Maybe you can tell me. You can tell me via writing. What's the issue? Because I know you have mic. Is there any issue? Oh, okay. There is an issue. Maybe you can use your, if you have muted the microphone, below the big blue button, there is a microphone, the one that I'm touching here. And maybe when I press it, I cancel. But now it should be blinking, so that now it is active. Column Madut, is there an issue? Grace, are you okay? Can you go to questions in chat room? So I will open a chat room. Okay. Madut, any question? Please, if there is a question, please ask. Eh? Okay, but here now we can meet in chat room. Okay, it's okay. Forex is offline. Are you in Forex? Okay, according to Grace, Grace is asking on multiplication table, and I can explain that. If you look at this multiplication table, I have trying to use a very simple interpretation where it has 4 rows and 4 columns. So already we have introduced this column. We have introduced that, and we have introduced the vertical and the horizontal. So we have introduced the horizontal and the vertical. So we are using vertical and horizontal to multiply and get the clear presentation for that. So when you're using this, what I have said, I can interpret this, maybe using the program here. And maybe allow me to use somewhere here. What I have said is that we need to introduce a variable int. Just a minute. So I have introduced a variable, and that variable I have called R, and another variable called C. Then I close that. Because we are introducing rows and columns. And when you introduce this, remember, I'm using a for loop. I have said a for loop is the simplest one to use. So I use for row is equals to 1. We can start with 1 or we can start with 0. Remember, when you start with 0, we don't use less than or equal to. When I use 1, I use less than or equal to. So I use row is equals to 1. Row is less than or equal to. How many rows do we have? 1, 2, 3, 4. So we have 4 rows. Then row plus plus. Row plus plus. Then we close that. So this becomes the outer loop. This becomes the outer loop. And it's the one that is controlling the inner loop. Remember, at the end, we don't use a semicolon in a loop. The only loop that we use a semicolon is a while loop, when you're using a do while. Then we can introduce this, and allow me to copy this. Copy. Then I paste. So here I introduce columns. Introduce a column. Now this becomes an inner loop. This becomes an inner loop. Then after that, remember what we have done is that we are multiplying rows and columns. And because we are multiplying rows and columns, now we have to introduce rows and columns. So allow me to introduce a variable that is called a result here. And then we can say result is equals to rows multiplied by column. So remember, according to the question that Grace has asked, She is asking, are we using incremental? Yes, we are using incremental because we have to increment from 1 to 4. So we have to increment from first column to fourth column. We have to increment from the first row to fourth row. So we must use an increment. And this is the increment that I have used here. And the same case we said, we can use what? This increment, 0, we can say is 0 is equals to row plus 1. If you want to increment with 2, we can use 2. If you increment with 3, we can use 3 or 4. It is on that. So in this case, I have multiplied the rows and columns. So when I multiply these rows and columns, I close this loop. So I'm closing the inner loop so that it can complete the multiplication. Then after that, I say printf. Then I use percentage %d. Remember, I want to display this result. Sorry. Then I use result. Then I close this. I hope that. Then I can close that. So in this case, I can still use a new line. Remember, if you're using this statement, we need to have a space between 1 and 2, 2 and 3, 3 and 4. So for this case, here, we can multiply this. Then when you multiply this, you can have a printf. We have a new line. Remember, this is a new line. And we close this. When you have this new line, here we can have a horizontal tabulation. We can have a horizontal tabulation. Or we can still say, let us first of all execute the first statement after you multiply. When you multiply the first one, execute. When you multiply the second one, execute. Then this one now, you come here and end at this point. So this is a clear program that will execute the way it has been aligned here, and it becomes easier. So I hope, Grace, I have answered your question. I hope, Grace, I have answered your question. Okay, there is another question Onyango has asked. Okay, yeah. Onyango, you have asked whether if I start with 0, it will still work. It will still work because 0 controls the number of 0 is the starting point. 5 is the ending point. But remember here, we cannot say R is less than 5. We need to say R is less than 4. Because when you count manually using your bare hands, 0, 1, 2, 3. Remember when you say less than 5, we are still counting 4. We are still counting 4. And remember here, we don't have 5 rows and 5 columns. We have 4 rows. So it is the same way we can say R is equals to 0. Then we say R is less than or equal to 3. That is agreeable. Because we have 0, 1, 2, 3. It can work. But we cannot say 5. Because when you say 5, you are counting 0, 1, 2, 3, 4. If you are using manual counting. Onyango, I have answered your question. Is it clear? Onyango, is there any question now? Peter, okay, Peter agreed that we can meet in chat room. So I would like to end there. And maybe if you end at that point, we can raise more questions in that. I will send these notes, and I want to send notes for today. Then for the next lesson, where we'll start on arrays, maybe we can have other questions. But before we start with the arrays, we will have a warm-up on what we did previously. That is today. That is next week. We'll have a recap. So let us meet in the chat room, please. Thank you for listening.